A thermal drone hovers over a nondescript warehouse in South Haven, Memphis. Through the lens, the building isn't just warm, it's glowing white-hot against the cool midnight blue of the Tennessee sky. This is the heartbeat of Colossus, xAI's massive supercomputer. But there's a catch. To keep these 100,000 GPUs running, they had to build something the local grid wasn't ready for. And the way they're doing it is genuinely brilliant, if a bit controversial. They aren't just plugging into the wall, they're building their own sovereign energy grid. In just 1,222 days, xAI transformed a former manufacturing plant into the world's most powerful AI training hub. That speed is unheard of in the world of industrial engineering. But as the GPUs spun up, the local utility, Memphis Light, Gas, and Water, faced a massive request: 150 megawatts of power. That's enough to light up 100,000 homes. When the grid couldn't deliver immediately, xAI didn't wait. They brought in the turbines. And that's where the thermal cameras caught something the public wasn't supposed to see. Recent drone footage exposed rows of natural gas turbines operating at the site. These aren't just backups, they are the primary engines driving the AGI race while the permanent grid connection is built. The problem? According to local environmental groups and the EPA, these turbines might not have the necessary air quality permits. It's a classic conflict between hyperscaling and regulation. But to understand why xAI is taking this risk, we have to look at the power wall. It's the invisible ceiling that every AI company is currently hitting. The power wall isn't a software bug, it's physics. As models get bigger, they require exponentially more electricity to train. We are moving from megawatts to gigawatts. Training a next-generation model isn't just about code anymore. It's about securing enough electrons to keep the lights on. This is why energy is the new silicon. If you can't get power from the city, you have to become the city. And that's exactly what xAI is doing in Memphis. But the scale of this project is hard to wrap your head around. We're talking about a facility that consumes more power than the entire city of South Haven itself. This isn't just a data center, it's a statement. It's a bet that the first company to solve the energy problem will be the first to reach AGI. Now, here's where it gets really interesting. Because xAI isn't the only one building their own grid. The entire industry is shifting. To understand the power wall, you have to understand the H100. A single one of these chips draws about 700 watts at peak load. Now multiply that by 100,000. That's just the chips. Once you add in the networking, the storage, and the massive cooling systems needed to keep it all from melting, the numbers get astronomical. The traditional electrical grid was built for steady, predictable demand. AI training is the opposite. It's a massive, sudden surge that can destabilize local infrastructure. This is why xAI deployed those 14 gas turbines. They provide behind-the-meter power, meaning they generate electricity right on site, bypassing the local utilities' bottlenecks. It's a brilliant engineering workaround, but it's also a regulatory nightmare. Natural gas turbines emit CO2 and nitrogen oxides, which is why the EPA is now involved. The conflict in Memphis is a microcosm of a global struggle. How do we balance the desperate need for more compute with the environmental standards of the 21st century? Supporters of the project point to the economic benefits. xAI is bringing high-tech jobs and massive investment to Memphis, a city that is eager to become a tech hub. On the other side, local residents are concerned about noise and air quality. They argue that even the most advanced AI isn't worth compromising the health of the community. This isn't a simple good versus evil story. It's a complex debate about priorities, and the outcome in Memphis will set a precedent for every other AI cluster in the world. To solve the power wall, companies are looking beyond gas. We are seeing a massive resurgence in interest for nuclear power, specifically small modular reactors, or SMRs. Imagine a data center that has its own carbon-free power source built right into the basement. That is the dream of the sovereign energy grid. But SMRs are still years away from mass deployment. In the meantime, the industry has to rely on whatever it can get its hands on, including those controversial gas turbines. The engineering required to manage this much power is staggering. We're talking about custom-built substations and cooling loops that move thousands of gallons of water every minute. Every watt saved in cooling is a watt that can be used for compute. This has turned data center design into a high-stakes game of efficiency. But even with perfect efficiency, the sheer volume of GPUs being deployed means the total power demand is only going up. We are in the middle of an energy explosion. Colossus is just the beginning. Elon Musk has already hinted at doubling the cluster to 200,000 GPUs, and some experts think we'll see million GPU clusters before the end of the decade. At that scale, the power requirements move from city-sized to state-sized. We are talking about a total transformation of how we think about infrastructure. The companies that win the AGI race won't just have the best algorithms. They will have the most robust, sovereign energy supplies on the planet.